Now there's some really weird roots that exist out there. Sometimes the radicand and the stuff, so that's the stuff underneath the root sign, is raised to a power. Sometimes it's the entire expression is being raised to a power as well. We can write these radicals, I know that was terrible, with a fractional exponent. So the index is in the denominator and the exponent is in the numerator. That's a little bit confusing. Let's take a look at like an example here. So we have our index n, and we have our radicand, which is x to the a. So we can rewrite that as x to the a over n. So the exponent of the radicand goes in the numerator. The index of this expression, that n, goes in the denominator. This would also be the same thing if we said n. So if we were to ask for the nth root of x and then we raised it to the 8th power, what would happen is we'd still get the same thing. We'd get 1 over n raised to the a. And what happens with that is we use our power to a power, which means that you multiply it in. So you just get x to the a over n power. Here's some weird radical roots. We're going to rewrite these. So we have 3 to the 2/5. Now, our index is 5, which means that our radicand, which is the 3, that's the base of our exponent. So the base of our exponent becomes our radicand. Our radicand is 3. Our index is 5. What's happening to that 3? It's getting squared. You could also write it as 5, so the 5th root of 3, and that's squared. Let's look at this one. So we're looking for the cubic root of 4 to the 5th. So our radicand here becomes our base, which means that 4 becomes our base here. 4 is being raised to the 5th power, and our index is the 3rd, so we're looking for 4 to the 5/3. 4 to the 5/3 power. Here we have a w being raised to the 3 over x. So w, which is our base, becomes our radicand. It goes underneath our radical. Our index is x, which is okay. It's just a number. And this is all I'm going to write it this way, is being raised to the 3rd power. So we're cubing that, and that's how we would write that one out. Here's another quick check. I want you to rewrite each expression. Take your time. These things are a little bit tricky. Just pause the video, go through it at your own pace, figure out what you can do. Let's simplify some radicals here. So we can simplify the stuff underneath the radical, so the stuff underneath the square root sign, by factoring. Remember, that's our favorite 6-letter F word. We want to look for sets of factors, and these sets of factors, if we want to like pull it out, we have to make sure that it's an n number set. For example, if our index is 2, then we want to be able to have like a set of 2. So like if it was, let's do 8, we want to say that we have these 2 here so we can pull them out. We have a set of 2. That doesn't mean that these have to be 2. Like this number, these numbers don't have to match this. It just means that we have to have 2 of them. So there's 2 of them here, and that matches our number there. Here's another example. We have the square root of 12 is equal to 3, or 2 root 3. Let's look at it. So our square root of 12, what we're going to do is we're going to do some prime factoring. That means that we're going to divide by a prime number until we can't, and then we're going to go to our next prime number. So 12, our easiest prime number is 2, so we'll divide 12 by 2. What we get is 6 and 2. Now we have our 6 here, so our 2 is a prime number. It can't be divided anymore, so we'll just leave it there. Our 6 isn't a prime number, so we can keep on dividing it. We're going to divide it by 2 because that's our easiest one to go for. So 6 divided by 2, that leaves us with 3. 3 is a prime number, 2 is a prime number, 2 is a prime number. Since our index here is 2, here I'll write it, so that's like an implied 2, we have to look for a set of 2 numbers. So we have to look for a pair. Here we have a 2 and a 2, so that's a pair of them, and we can pull them out. We can also rewrite it as the square root of 2 squared times 3. Our square root sign is going to get rid of that squared there, and we can pull this number out of the expression, so we get 2 times the square root of 3. Let's do this example here. These are some really mean ones. I had to pull out a calculator because I haven't actually looked at them yet. We're going to try and split 320 up. Let's divide it by 2 real quick. So if we divide by 2, we get 2 and 160. 160 looks like it should be divisible by 2. Let's do it again. So we get a 2 and an 80. 80 still looks divisible by 2. We'll divide by another 2. So we get a 2 and a 40. This is going to give us a 4 and a 10. 4 goes into 2 and 2. 10 goes into 2 and 5. Let's start going through these ones. Here's one pair. Here's 2 pairs. So what's going to end up happening, we can pull out 2 pairs of them. When we pull them out, we're just going to multiply them together, so we have a 2. So this becomes a 2 on the outside. This becomes a 2 on the outside. So we're going to end up with 2 times 2, which is 4. And everything else that couldn't be pulled out, we had to plug straight back. Oh, there's another one. There's another set. Oops. So this is actually 2 times 2 times 2, which is 8. 8, and the only thing that's left over is a 5, so that's how we simplify it. This square root of 320 is actually 8 times the square root of 5. I'm going to leave this one to you guys. Just remember here, you have to look for a set of 7. So you'd have to have, like, if you divide this by 2, you'd have to make sure that you have 7 2s that you can pull out at once. So here's a quick check. Let's simplify these expressions. Go ahead and pause the video and do that. This will be the last quick check of the video. This one is just really tedious. It takes a lot of work, but it's not as bad as rewriting them. So it can be frustrating, but it's okay. You'll get it.